Welcome to another math lesson. This is Mr. Pi. Today we're going to be talking about Prentice Hall Geometry, section 10.6, circles and arcs. This will be part 1. The main focus on this will be defining parts of a circle and arcs and working with central angle measures. Let's get this party started. In a plane, a circle is the set of all points equidistant from a given point called the center. You may name a circle by its center. Circle P is shown at the right. Let me show you this notation here. Circle P, might want to highlight that or underline that. That would be red circle P. All it is a little circle with a dot in the middle. Here we have circle P. It has the center P. A radius is a segment that has one endpoint at the center and the other endpoint on the circle. Segment PC is a radius. That would be this segment right here, P to C. That would be segment PC. Segment PA and segment PB are also radii. That would be this segment here, PA, and this segment here, PB. Those two segments are radii. Congruent circles have congruent radii. Next, we're going to talk about the diameter, and a diameter is a segment that contains the center of a circle and both endpoints on the circle. Segment AB is a diameter. So here we have segment AB, and it does go through the center point P. Therefore, it is a diameter. I want you to notice that in this diagram that these two radii, segment PA and segment PB, make up one diameter. So two radii make up one diameter. A central angle is an angle whose vertex is the center of the circle. Angle CPA is a central angle. So angle CPA, this angle right here, is called a central angle. And that our next example, or the first example, really example 1T, is dealing with central angles and central angle measures. Here we have a pie chart. Example 1T reads, a researcher surveyed 2,000 members of a club to find their ages. The graph shows the survey results. Find the measure of each central angle in the circle graph. So, pretty simple thing to do. What you need to know is that the total number of degrees in a circle is 360, and this really boils down to a basic percent problem. We're going to start with the ages 65 and up, which consists of 25% of the circle graph. So that would be the basic percent problem, 25% of 360 degrees. And if you remember, of translates into multiplication. We convert 25% into its decimal form, which would be 0.25. And you would multiply that by 360 degrees to get the angle measure of this. Hopefully, you understand that that's 90 degrees. You could just divide 4 into 360 also. This is a 90-degree angle here. Remember, our goal is to find the measure of each central angle. Next, we're going to move on to 45 to 64-year-olds, which would be 40% of the 200. We're not going to do this step here. We're just going to write it out as something we can enter into a calculator. That'd be 0.4, or 40% times 360 degrees. And that's going to give you 144 degrees. Now, you could do that by hand, or you could use a calculator. 0.4 times 360, get the 144, and understand that the answer is degrees. So that was that age range there. The next age range we're going to look at is the 25 to 44, which would be this here, this 27%. 27% as a decimal would be 0.27, or 27 hundredths, times 360 degrees. And run that through your calculator. It's going to give you a decimal number. It's going to be 97.2. And that would be degrees. So now we know the measure of this angle here. And finally, now you could do this a couple ways. We're going to work with this age right here, represented with 8%, which would be the under 25 population. And that would be 0.08. That is 8% as a decimal. A lot of kids make the mistake to make this 0.8 for some reason. That's actually 80%, so 8% of 360 degrees. and that would give you 28.28 degrees. 28.8 degrees. So there we have found the measure of each central angle, and if we were to add those up, that would give us 360 degrees. This has been Mr. Pi, and we've been working with the measure of central angles given the percents in a pie chart.